Today I am going to tell you about the sites of action of drug on synthesis, storage, release, action and the fate of the norepinephrine. So I will start with the formation of the tyrosine. So how the tyrosine is formed. First one is the phenylalanine, which is the essential amino acid which is absorbed from the GIT and it enter into the circulation with the in the liver. So there are presence of hepatic hydroxylase enzyme which is responsible for the conversion of phenylalanine into the tyrosine. Then the tyrosine is converted into the DOPA, which is a precursor for the dopamine. As we know, the dopamine is the neurotransmitter in the peripheral nervous system and central nervous system. So tyrosine is roaming in the circulation. It is entrapped by the sympathetic neurons. Then the neuron terminal, here is the tyrosine. Tyrosine gets converted into the DOPA with the help of tyrosine hydroxylase. This enzyme is inhibited by the alpha methyl tyrosine. Alpha methyl tyrosine. So tyrosine converted into the DOPA and hence the DOPA converted into the dopamine with the help of L-aromatic amino acid decarboxylase. This enzyme is responsible for the conversion of DOPA into dopamine. Here the inhibitor is carbidopa. Carbidopa, which is a drug used in the Parkinson's disease. We all know that Parkinson's disease the dopamine is deficient. So the carbidopa, which is responsible for the inhibition of conversion of L-DOPA into dopamine in the peripheral nervous system, so that there will be a no conversion of L-DOPA into dopamine. So in central nervous system the L-DOPA is available as a precursor for the synthesis of the dopamine. So there will be a fulfillment of the dopamine in the central nervous system. So further we will move what will be the fate of dopamine. Here the dopamine and dopamine gets converted into the norepinephrine. Then it will combine with the 4 molecule of ATP and one substance known as the chromogranin A. These all are fitted into a vesicle, and here the vesicular membrane. The vesicular membrane is ruptured by the calcium influx by the calcium channels. Here one drug, reserpine, which inhibit the entry of dopamine into the synaptic vesicles, and hence it makes the wall very fragile. So there will be a rupture of the wall of vesicle, and the norepinephrine is available freely inside the synaptic buttons or synaptic terminals. Here the calcium influx by the calcium channels, so there will be a release of norepinephrine into the synaptic cleft, and the response will be on the alpha 1, beta 2 and beta 3 receptors. Here it will act, and the presynaptic receptors are beta 2 and alpha 2. Here it is having also action on the alpha 2 and beta 2. Thank you.